Welcome to the very first of our recorded lectures. I'm new at this. I hope it'll turn out okay. We're going to start off with the senses. I'm recording from my home, which means that there is a pretty good chance in the course of these lectures that you will end up seeing at least one of my cats. All right, I will introduce them as they show. In the meantime, we're talking about the senses. Now, we just finished talking about neurophysiology. And with neurophysiology, we learned that neurons were special cells that were what we described as excitable. These excitable cells can take the input, which we said were graded potentials, and turn that chemical signal into an electric signal, which is the action potential. These cells of the sensory nervous system are even more highly modified. They're really super modified neurons. So they are still excitable cells, they're still neurons, but they have this clever way of being able to take the energy from something else, something outside of your body, and turn that into an electrical signal, an action potential that can be delivered to your brain. The only way you know that there is a world around you, the only way you know that you even have your own physical body, the only way to know that is by these things that we call our senses, all right? So the sensory systems are the means by which organisms like you and I receive signals from the external world telling you, hey, I'm at home, and yeah, I should turn on the heater or whatever, or from the internal environment. When you close your eyes, you still know where your hands are, right? The reason that you know that is because you have got sensory neurons that are telling you where your hands are. More than that, we will be talking about how your body knows what your blood pressure is at any given moment. How does it know that? Sensory neurons, okay? So we're going to call them sensory receptors. It might be a little more accurate to call them sensory receptor cells or sensory neurons, but these are cells that can detect energy, and when they do, they turn it into an electrical event, an action potential, and send that to your central nervous system. So I'd like you to notice, I'm going to try and use a marking pen, that there is information that goes from the outside towards your brain, and these are sensory, and then there are neurons that are busy doing integration. They're deciding, what does this mean? And in the sensory nervous system, that integration is called perception. So sensing the presence of a sound, that is the province of your sensory neurons, but perceiving that that sound is a guitar, that is going to be a function of integration. That's a function of your central nervous system. And then the last step, what color will we make it? Here we go. The last step is here, and that is going to be motor, and that's going to be information, commands, if you will, going from the central nervous system out to perhaps your muscles, right? So remember that sensation is not the same thing as perception in physiology. Sure, in regular old English, it's nearly not that different. But when we're talking about the sciences, sensation is just awareness of a stimulus, like, that's a weird smell. What is that smell? That is sensation. Perception is when your brain goes, aha, that is a touch of oregano that's been added to your pasta, okay? That's perception. So sensation and perception, not the same thing. So here is one of the cool things about this system. Your brain needs to know not just that you are experiencing something, but what it is you're experiencing, but the nerve cells, the neurons that carry information from your fingertip to your brain are exactly the same, completely interchangeable with the sensory neurons that carry information from your nose to your brain, okay? So the sensory neurons are the same. Here's another thing. I want you to remember that action potentials, they were all or none phenomenon. They either happen or they don't. And since they either happen or they don't, that means that they are all the same. So the neurons are interchangeable all the same, and the action potentials that they carry are all the same. So how does my brain know that I just tasted something sour? How does it know that and knows that I did not just hear the doorbell ring? All right? Now, the basic way that your brain knows is by the way the neurons are hooked to the different parts of your brain, okay? So, for example, here in my house, there are 2 doorbells. There's one for the front door, there's one for the side door. No, that's a bad example. Let's just try a totally different thing. Let's look here on our diagram. So if I have got a nerve in my nose, and the nerve in my nose wants to tell my brain, hey, I just smelled something, that nerve, let me go from here. That nerve is going to start right here in my nose, and it is going to go here, boom, to the olfactory bulbs. When an action potential arrives in my olfactory bulb will perceive it as a smell. Now, let's do a different one. Let's imagine that I have got a nerve out here. It's going to be out here, right here in my ear, and that nerve is going to be connected to this part of my brain. If an action potential starts out here in my ear and it ends up here in this part of my brain, then my brain is going to perceive the arrival of that electrical event as a sound, right? Same thing, if something starts out here at my eye and ends up being linked up here to the occipital lobe, my brain is going to perceive that as vision, right? Now, what about the intensity? What about the intensity of an experience? Let's say sometimes something tastes sour, sometimes it's like, oh, super sour, right? So the way your brain knows that something's a little bit sour or a lot sour is 2 ways. If there's just a couple of neurons that are telling my brain, hey, I taste sour, my brain will go, oh, that's a little bit sour. If it's a lot of neurons, my brain will say, oh, that's a lot sour, okay? Now, on top of that, what else? How frequently the action potentials are sent, right? So if one of my neurons is sending out action potentials, kind of like a beep, kind of like beep, 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 that would be like a little bit sour. But if that same neuron was sending it out like this, beep, 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 then that neuron would be saying, hey, a lot of sour, right? Now, let's move to this concept that may or it might not be related. This is the concept of synesthesia, right? Synesthesia is the idea that for some of us, not all of us, but for some people, we will taste a sound or hear a smell or smell a color. And you're like, okay, well, how would that happen? Well, we actually don't know all the reasons that it does happen. But one reason we think it does happen is this. Actually, let's go back to my last image. Oh, it won't let me go back. That'll be a problem. So one of the reasons that it can happen is this. It can happen that there was a neuron that started in my ear, and so it sends out an action potential when the right sound hits it. And that little neuron, its axons, it grew from my ear, and it's supposed to grow from my ear, and it was supposed to go all the way over into the temporal lobe of my brain, but it got lost. And on its journey from my ear to the temporal lobe of my brain, it got caught up with the wrong neurons, and it ended up going to my occipital lobe. if that happens, then when this neuron fires off an action potential, because there is a sound there, then that sound will be perceived as a color. And so there are people, somewhere around 5 to 10% of people, that this happens, not a lot, but a little bit. Like they will say that the doorbell tastes a little bit sour when it rings, or that when they hear a certain key on the piano, that it smells like lavender, something like that. And that's known as synesthesia. But let me show you something else about synesthesia. I want you to look at these two images here. I want to look at these two gray images that are here on the slide, and I want you to tell me, of these two gray images, which one would you name Kiki and which one would you name Booba? Kiki and Booba, all right? Now, if you're like 98.9% of people on the planet, you are going to either name this one Booba and this one Kiki, or you're going to name the one on the right Kiki and the one on the left Booba because it appeals to you to name it backwards, all right? Now think about how crazy that is. First of all, these are not even really hardly two-dimensional images. You could not touch them with your fingers, right? You can't handle them, you can't turn them around. And yet, to like 98.9% of people on the planet, the one on the right should be named Booba and the one on the left should be named Kiki. And like I said, for those of you who named the one on the right Kiki, it was just because you thought it would be funny to name it Kiki, right? But by thinking it's funny to name it Kiki, that already admits that you think it really should be named Booba, right? But why? Well, if you ask people, people will say Kiki is a sharp sound and Booba is a round sound. Okay, we already have a little bit of synesthesia there, right? So a little bit of synesthesia because a sound is not something that you can touch, and round and sharp are tactile sensations, right? Then you go a step further and you're looking at something. So these shapes, they're not anything you can touch either. And yet we know that if they were real, if they were three-dimensional, the one on the right would be round and the one on the left would be sharp, right? And it's because of that that we think it's obvious which one should be named what. Synesthesia is probably not a bug in the system of human physiology. It is probably a feature, meaning it's probably one of our actual strengths, that humans can take input from different sensations and synthesize them in a way that allows us to have tremendous creativity and also perhaps create very creative solutions to the kind of problems that we face. Alrighty, that's it for my first lecture, and look for lecture B to continue this lecture.